Hello everyone, we are here at the Optical Fiber Conference 2024 in San Diego, and I'm here at the Eoptolink booth with Dirk Lutz. Dirk, everybody is talking about linear pluggable optics and you have quite an impressive demo here. Can you walk us through the demo setup?
Sure, and welcome to our booth. So what we are having here is two 51.2 terabit switches. On the left side we are having an Arista switch. On the center we are having a switch from Broadcom Technologies. We are showing in this demonstration 800G LPO pluggable modules, and they are performing very well. The bit error rate is usually in the order of 10 to minus 11, 10 to minus 12. On the center side we are showing a comparison between LPO modules and retimed modules. The LPO module configuration is from the switch to a server and to the NIC card, which is representing the GPU in AI ML networks. And we're demonstrating retimed modules versus LPO modules.
And Dirk, I see a fiber running there, and at the top, where are those fibers going?
So what we are showing here is a 300-meter AOC link to the Arista booth, and they have another Arista switch in their booth. So these two are connected. And the second fiber here, this one is going to our immersion cooling demonstration.
Very good, Dirk. And if you look at the power consumption, so linear pluggable optics, if you compare that to standard transceivers or if you compare that to linear receive optics?
So an LPO module usually has about an 800G LPO module. It's usually about 50% power, less power consumption. And compared to a half retimed module, the half retimed module is somewhere in between the LPO module and the DSP-based module.
And then, Dirk, this is 8 by 100, so 100 gig per lane. How about LPOs for 200 gig per lane? Is that also possible, or how far are you with 200 gig per lane?
This is possible. We are demonstrating it inside in the private room. What we are showing there is a 200G per lambda lane of 800G DR4 LPO towards a 800G DR4 retimed. And by this we are demonstrating both the half retimed situation for the TX and the RX at the same time.
Very good, Dirk. So then maybe we look where this fiber ends and go to your immersion cooling demo.
Yes, that's a fun demo.
Very good. So now we are at the other end of that fiber from the LPO demo, and now, Dirk, you show immersion cooling. All the state-of-the-art AI servers use immersion cooling simply to get the heat off the GPUs and save energy. You demonstrate here that your optics are also ready for immersion cooling. What did you need to do to actually get it underwater?
Yeah, let me first explain the setup. So in immersion cooling, all of the electronics and optics are submerged into a liquid. The basic idea is that the liquid transfers the heat more efficient than the air. So it's a more efficient way of cooling. Tricky part was that the index of refraction of the liquid is 1.5, which is different than the one from the air. And we had to design the module in a way so that the optical path is not interfered by the liquid.
And from a power consumption perspective, do you have any advantages if you do liquid cooling?
Yes, definitively. First, the operating temperature of the module is much lower. So this one here is in operative mode now at 37 degrees Celsius, which is much lower than the usual temperature of 60 degrees. One of the possible advantages could be that the lifetime of the modules could be much longer because of the lower operating temperature.
Excellent. So you could really say it's a cool demo,
yes.
Right? Impressive.
Thank you.
Another hot topic here at OFC is 200 gig per lane. And Dirk, you are showing both your new single mode and multi-mode transceivers for 200 gig per lane. Can you walk us through some of the highlights and maybe start with single mode?
So what we are demonstrating here are our 800G single mode transceivers. And what we are showing here is 3 different modulator types. So the first 3 on the left side are DR4 modules. We are showing different modulator types: silicon photonics, thin film light niobate, and EML as modulator.
Yeah. And you are sampling those today. When will you ship in volume?
We are sampling today, and we ship in the second half of the year. we start to ship them in volume. And later this year, but in the end, we will also release the 1.6T OSFPs.
Very impressive, Dirk. So the GPUs are all connected today with 100 gig per lane with VCSEL technology, and that needs to be upgraded to 200 gig with 200 gig transceivers, multimode transceivers and VCSELs. And Dirk, I think very impressive, your most exciting demo, industry first, 200 gig per lane multimode, you're using the Broadcom VCSEL. Can you tell us how far along you are with your multimode 200 gig per lane?
Yes, sure. So first, this year is, to our knowledge, the first demonstration of a 200G VCSEL, eye diagram and transmission. So, and there are two enablers for this. Broadcom released a few weeks ago the 200G VCSEL, and the second part that is enabling is that we got the 200G DCA from Keysight. In the demonstration, we're showing both the eye diagram and a link from transmitter to receiver with the pair which we are demonstrating.
And this is a technology demonstration, Dirk. You know, how long do you think it takes until you ship in volume?
This here is a technology demonstration. We still need to get the subcomponents like the laser drivers. We're using currently an EML laser driver, which gives not the best performance. So it's more than a year left to a ready product.
Very impressive, Dirk. Congratulations.
Thank you.
So now we look at the final demo. Dirk, you have your 800 gig ZR module here. What are some of the highlights of your Coherent ZR optics?
So what we are showing here is our 800G OSFP ZR module. It has a tunable output power from -5 to 0 dBm. The receiver can handle optical signal to noise ratio of 26 dB. And transmission distance is up to 120 kilometers. On the equipment we can see a very good constellation, and yeah.
Very good performance. Impressive, Dirk.
Thank you.
And here you have your 400 ZR optics.
This is correct. It's our third generation module. So in this module we are using now our own silicon photonics PIC and our own ITLA.
And those units are shipping, right? And the 800 gig?
The 400G ZR is shipping. The 800G ZR is being sampled to selected customers.
Very good, impressive, Dirk. Thank you so much.